The advent of technology brings about many advantages in today's society, one of which is the wide use of gadgets and machines. But have you ever wondered why all of these are possible? Have you ever thought how electricity affects us in our daily lives? As beings who consume electricity on a daily basis, it is necessary for us to understand its interrelated concepts. In today's episode, we will be focusing on the electrical resistance of pencil leads to a simple circuit. Electric current is the rate of electric charge in motion. It can be brought into being by a sudden emission of electricity, which resulted from the imbalance of positive and negative charges on the surface of a material. One of the most practical means involving the idea of electric current can be witnessed through electric lighting. Although the lighting of bulbs is made possible by the flowing of electrons, it still has to be regulated because it may cause danger to all, especially to human beings. Resistors play an important role in electric circuits. Its main function is to control the amount of current flowing in its components. If too much electric current is streaming in a material, it has a high chance of being destroyed. Resistors can prevent this from happening because it could limit the current. Because of this, resistors may also be able to put people to safety. This experimentation aims to determine the electrical resistance of pencil leads to light circuits. Hence, it aims to answer the following questions. First, can the lead of a pencil be an effective resistor? Second, does the length of the pencil resistor affect the brightness of the bulb? Before conducting the experiment, one must gather the following materials needed for the study. AA batteries, AA battery holder, alligator clip heads, mini light bulb, mini bulb screw base, number 2 pencils, metric ruler, pencil sharpener, and coping saw or cutter. The following are the primary steps and procedures in conducting the experiment. Place 2 AA batteries into the battery holder, making sure that the same charges line up with each other. Attach and connect the red alligator clip to the exposed metal part of the positive connection of the battery holder. Attach and connect the black alligator clip to the exposed metal part of the negative connection of the battery holder. Use a small screwdriver to lightly loosen the screws of the bulb base. At the other end of the black alligator clip to one of the slackened screws of the bulb holder. Connect one end of the other black alligator clip to the other slackened screw of the bulb holder. Screw the light bulb into the bulb holder. The circuit to test by putting the exposed metal ends of the red and the other black alligator clips into contact. The bulb must light up since this creates a closed circuit. If the bulb did not light up, inspect and examine the following. Assure that the connections of the alligator clips are not loose. Assure that the light bulb is firmly fastened into the base. Lastly, assure that the batteries are inserted accordingly. Sharpen all the pencils at both ends, making sure that they have varying measurements. Connect the graphite tips of each pencil resistor to the free ends of the red and black alligator clips. After a series of researches and observations, it is concluded that the lead of a pencil can indeed be an effective resistor. Graphite is known as a conductor. Conductors tend to have low resistance while insulators entail high resistance. In this study, the capacity of the pencil lead to resist the electric flow was tested. It is shown that the amount of graphite involved affected the light from the bulb. Since it is a conductive material, it allows electrons to freely move onto it. This also means that as the conductive material increases its length, the amount of resistance increases as well. This is because electrons will have more collisions before they could even reach the other wire that connects to the circuit. It is also concluded that the length of the pencil affects the light coming from the bulb. As the alligator clip heads were attached to the graphite tips of the shortest pencil, it is apparent that the light which the bulb gives off becomes dimmer than the usual. The same thing happens when the alligator clip heads are then fastened to the other pencils in succession. In fact, the bulb did not emit any light at all when the longest pencil prevented the passage of the current along the circuit. Before putting this video into an end, let us first have a short recap of what we have learned today. Resistance is the measure of the difficulty of the passing through of current in a conductor. This is emphasized in the study by means of using the graphite center of pencils. Why is it relevant and essential? To answer that question, let me put this in a simple analogy. Let us compare the resistance of electric current to the flow of water through pipes. The resistance to the flow of charge in an electric circuit can be compared to the frictional effects between water and the pipe. It is this resistance that hinders the water from flowing, thus reducing its drift speed as well. Like the resistance to water flow, the total amount of resistance to charge flow within a wire of an electric circuit is affected by some clearly perceptible variables. It is very important to understand these concepts, especially to those who deal with them every day. This is the reason why the researcher chose to venture on this particular topic. Well, I guess that is all for today. Thank you for watching.